If you're building your own fan and feel overwhelmed by the electrical system, this is the video for you. Because this is the part where most people either overcomplicate things or make expensive mistakes. We converted this entire fan ourselves into a fully functional tiny home. I'm Brandon and I'm an electrical engineer. And I designed a complete electrical system. By the end of this video, you know exactly how to approach your own system. Before we dive into the system, it's important to understand the language of electricity. If you already know your volts from your watts, feel free to skip to the next chapter. But if you're starting from scratch, this is the best place to begin. Imagine electricity is water. This helps us visualize the four main components of power. Voltage is measured in volts, current is measured in amps, and power is measured in watts. And finally, capacity measured in amp hours or watt hours. Voltage is the push or the pressure behind the electricity. High voltage is a high pressure power washer. Low voltage is like a gentle garden hose. In standard Europe wall sockets, the pressure is 230 volts alternate current. However, in a camper or in a van, we usually work with direct current 12 volt, 24 volts or 48 volts. Amps is the volume of electricity flowing through a wire at any given moment. High amps is like a thick fire hose moving a massive amount of water, while low amps is like a thin straw moving a tiny trickle. If you pull too many amps through a wire that's too thin, it creates a friction which turns into heat. This is why we use fuses, to stop the flow before the wire gets too hot. Wattage represents the total amount of work being done. It is the result of the pressure, volts, multiplied by the flow of amps. High wattage our devices include things like electric kettle, which needs a lot of energy to create heat. Low wattage are devices that things like a small bulb. You can calculate power by using the simple equation, watts is volts times amps. While the amount of watts tells you what is happening right now, amp hours tells you how much energy you have stored. Think of this as the size of your water tank. A 100 amp hour battery means the tank is large enough to provide a flow of 1 amp for 100 hours, or 10 amps for 10 hours. It's simple, if you increase the flow, the tank empties faster. This is the brain of the entire system, the electrical cabinet. This is where everything comes together, and at first glance it can look a bit overwhelming. But once you understand the logic, it's pretty simple, and that's exactly what I'm trying to do with this video. Think of it like a control room. Power comes in, gets managed, protected, and then distributed to everything in the fan. Let's walk through it. We start with the master battery switch. This is the main on-off if needed. You can shut down the entire system instantly. Then we have the Victron Smart Shunt. This sits between the battery and the rest of the system, and it measures everything: battery percentage, power usage, charging, all your data. Think of it like a fuel gauge, but more accurate. Next is the link distributor. This is basically a central fuse box for your big components. Each major device has its own fuse. The inverter, the solar charger, DC to DC charger, battery protect, and the servo. So if something goes wrong, it's isolated and protected. And that's very important. Always fuse every major component, so when one thing breaks, it doesn't take your whole system down with it. Now the biggest unit here is the Victron Multiplus. This is your inverter and charger in one. It converts your battery power to 230 volts alternate current and also charges your battery when you're plugged into shore power. It can handle up to 2400 watts of usable power. And then we have the solar charge controller, the MPPT 100/30. This takes power from the solar panels and converts it into usable energy for your batteries. And then the DC to DC charger. We upgraded to the 50 amp version, so while driving it charges the battery up to 50 amps. So driving becomes a reliable charging source. This was a little different for our new model out 2021 Fiat Ducato, which is in Euro 6. So if you have or will buy a Euro 6 model, make sure you stick around to make this work. And then there is the battery protect. This is the safety feature that disconnects all DC loads if the voltage of the battery gets too low, so you don't accidentally drain your system completely. And we also made this manual switch in the front of the fan of it, so we can completely shut it off. Now, tying everything together is the Servo GX. This is basically a communication hub of our system, like the main quaders. It connects everything, sends data to the display and allows remote control. We also use it in a smart way. It powers the LED indicators on the link distributor as a small hack to avoid the needing a more expensive component. It also has two relays on board, one of the grey water valve and one as backup switch for the water pump. So again, more control, more safety. Then we have two separate fuse blocks, one for 12 volt for all your DC loads like fridge and a pump, and the other one for 230 volts for your EC system. The 230 side runs to the multiplus and is split into different groups. For cooking top, outlets divided around the fan, above the kitchen counter and the boiler. Each again with its own breaker. So everything is protected, organized and easy to troubleshoot. And that's really the key idea behind the whole cabinet. Keep it structured, protected and logical. Because once something goes wrong, and at some point something always does, you want to understand your system quickly. Alright, let's talk about the most important part of your entire system, the batteries. Because if you get this wrong, nothing else really works. Your fridge, your lights, even how long you can stay off grid, it all depends on this. So here is exactly what we did and why. We are running 4 Lithium self-heated 100 amp hours lithium batteries. That gives us a total of 400 amp hours. Now the choice wasn't random and there was one feature that really matters here. These batteries heat themselves, and that solves a problem a lot of people don't even realize they have. Lithium batteries cannot safely charge when it's cold. Below around 0 to 5 degrees, you can actually damage them. So what happens in the winter? A lot of systems just stop working properly. And these don't. They automatically warm up before charging, which means we can use the system year-round without thinking about it. Besides that, we also have our heating system warm up the garage area. Now, let's make this practical. This is where most people get stuck. How much battery do you actually need? The simplest way to think about this, your battery is just a water tank. We explained it in the beginning of the video about amps, amp hours, watts and voltage. But here is the important part. We didn't size it for average use. We sized it for the worst case scenario. Because we went fully electric in this fan, including cooking. So no gas at all, which means our usage is higher than most fans. So we calculated everything. Fridge, lights, charging, cooking, especially with winter in mind, because there is less sun and storage capacity is less available in cold conditions. At our most demanding scenario, we use about 120 amp hours a day. That includes using the induction hub twice a day, once for coffee or tea and once for cooking. The fridge is 24/7 on, and lights, etc. So in the worst case scenario, no driving, no solar, no shore power, we can last about 3 days. Well, fun fact, in reality it's a different story. We actually stayed off grid for up to 4 weeks, just by driving a bit most of the days, and 2 weeks of cloudy weather. So the system gives us both security and flexibility. But there's a thing people often overlook, and this one really matters. It's not just how much energy you have, so water in the tank, it's how much power you can deliver at once, how much water you can tap at once. Each of these batteries has a 100 amp battery management system. It's called the BMS. This BMS is important because that's what tells you how much water you can tap at once, how much energy you can tap at once. So together that's up to 400 amps of output, which means we can actually use the full capacity of the system when it's needed. And that's exactly why we did not go for the AGM or low acid batteries. Those are two other often used battery types, but only gives you a fraction of their capacity as usable power. And that's when you run into issues, like your inverter shutting off when you need it the most. Lithium completely avoids that. Now looking at the setup itself, the batteries are installed in the garage, above the wheel arch, besides a dedicated electrical cabinet. But more importantly, it's accessible, because if something goes wrong, you don't want to take your whole fan apart just to fix it. Now before you build your own system, here are my top tips. Don't underestimate how much power you use. Think about the temperature limits, especially with standard lithium batteries. Never mix different battery types in one system. If you plan to travel in cold climates, consider self-heating batteries. Always calculate both capacity and outputs, so amp hours and amps. You might have enough amp hours, but not enough actual power output to run all your devices. So look at the BMS on your batteries. Now that you understand that, you're already ahead of most people. That's what keeps your system reliable when it really matters.
If you liked this video, then please give it a thumbs up. It really helps the video reach more people and help us create more useful and informative content for you. It's the easiest and of course completely free way to support us.
So now you know how we use and store power, but how do we actually charge it? We use three main sources: charging while driving, solar and shore power. So let's start with charging while driving, because this is where things get a bit tricky with our model. There are different alternators, and it depends if you have a classic or a Euro 4, 5 or 6. Where on the Euro 4, 5 and 6 they will probably be a smart alternator. And we have a 2021 Euro 6 Vio Ducato. That means it does not give a constant charging signal like older fans. So let's dive into how charging works across different engine types and specific scenarios you need to keep in mind. With the classic alternator, you can charge your house battery using either a DC to DC charger or a Pacific split charger relay. In this example, we are using a DC to DC charger with automatic engine detection. We have set the threshold to 13.2 volts, meaning the charger only activates once the voltage stays above that level. And this is exactly where the voltage will be or more when the engine is running. If you have a Euro 4 or a Euro 5 diesel engine, you are dealing with a smart alternator. To save energy, these alternators scale back in voltage once the starter battery is full. This causes the voltage to drop below 13.2 volts, which accidentally triggers the DC to DC charger to shut off. This creates a constant on and off toggling, which is exactly what you want to avoid. The solution here is to connect the D+ signal from the smart alternator directly to the DC to DC charger, specifically to the H contact point on the Victron unit. The DC+ wire provides roughly 12 volts only when the engine is running, allowing the charger to stay activated regardless of the voltage fluctuation. With the Euro 6 diesels, like our Fiat Ducato 2021, a traditional D+ signal no longer exists. Instead, the fan uses a CAN bus system, which does not communicate directly with the Victron DC to DC charger. Since there is no D+ signal, you are forced back into the automatic engine detection. And that brings us back to an annoying switching problem once the starter battery is full. We have come up with a workaround to stop this switching on and off behavior once and for all. Here is how our process works. We made a live signal directly from the ignition switch and ran it through an additional on and off switch near the driver's seat. Now the charger receives a signal as soon as the key is turned. However, this is not a true D+ signal, because the charger will try to pull power before the engine has even started. To solve this, we installed a time-based relay with an offset of 2 minutes. This means the DC to DC charger only starts charging 2 minutes after the ignition is turned on. This protects the starter battery from being under heavy load while you're actually cranking the engine. Plus, if you ever need to have the engine on while parked, we can simply use our manual override switch to keep the charger off. Next up is the solar. We are running 400 watts solar panel on the roof, connected to the Victron MPPT 130. We choose this specific panel because of its size. Our roof is quite full, with a roof window and a fan, so we needed something compact but still powerful. This one uses IBC technology, which improves efficiency, so even with limited space, we still get a solid performance. And this is what keeps us going most of the time. Especially in the summer, solar does the hefty lifting. And finally, shore power. This is a simple way to power your fan. Just plug into campsite and the system handles the rest. No setup, no thinking, it just works. At the heart of this process is our Victron Multiplus. This is not just a simple charger. It's a powerhouse that charges our batteries with a massive 120 amps. To give you an idea, something we just learned, a charging voltage of roughly 14.4 volts. That's over 1700 watts of power flowing in your battery bag. But the real game changer is the feature called Power Assist. Sometimes a campsite power supply is limited. For example, only 4 to 6 amps, which usually is not enough to run heavy appliance, like a coffee machine or a hairdryer. When that happens, Power Assist automatically kicks in. It takes the limited power from the source connection and assists. It's by adding extra energy from your batteries. This way you can still use heavy appliance without tripping the campsite fuse. Once you're done, the multiplus goes back to topping up your batteries. So these are the 3 ways we charge our system. It's by solar, by driving and by shore power. And together they give us a really flexible system whenever we are moving, parked in nature or at the campsite. Now let's look what we actually use all that power, because this is where your battery size really comes from. It's important to have a look at everything you want to run in your fan. If you have an overview of all your appliances and how much power they use, then you can look at your battery capacity. So start with your appliances, then size your system. So that's exactly what we did. Starting with the lighting. 7 LED spots in the ceiling, plus a LED strip in the back for indirect lighting. Very efficient, but since you use them every day, it adds up. Then the small stuff. Charging phones, iPads, laptops. We have got USB outlets under the table and an additional USB-A and USB-C chargers near the storage and camera area. Plus a 230 volt outlet. Individually small, but together a constant load. Next, the water system. We are using a SureFlow Trail King 7 liters water pump. It's controlled by the main panel with an on-off switch, but also remotely by the servo. Then you got your always-on high-impact system. The fridge, for example, a CN Comfort CR85X. It's an 85 liter running 12 volts on an LG compressor. We chose the largest one that could fit, and I think that's a good tip. Always go as big as your space allows. Because it runs 24/7, it's one of our main consumers. For heating and hot water, we use a DCE diesel combi boiler. It's not an official Truma, but it looks and works exactly the same. It gives us about 10 liters of hot water and heats the entire fan through 4 outlets, all controlled on the thermostat at the control panel. Then there is ventilation, our roof fan, plus things like radio and our 4G modem for internet. And finally, let's talk about the cooking. We've opted for a 2-burner induction hob. While it's capable of reaching 3600 watts, we have limited the output using load balancing to perfectly match our inverter capacity. It was a bit more of an investment than a standard hob, but in our opinion, it's worth every penny. It takes the guesswork out of cooking. You never have to worry about managing the power yourself. Without this, you're risking triggering the system safety shutdown or blowing a fuse right in the middle of preparing dinner when you're off grid. That's a situation you definitely want to avoid. On that note, a pro tip here for any fan builder is to always carry a spare fuses for every single component in your system. However, a well-designed power management system like this, you should probably never need to use them. Now here is the key step. We've added up power usage of all our devices. Think of it like budgeting. If you don't know what you're spending, you don't know how much you need. And that's how we landed around 120 amp hours a day. That times our requirements to spend a minimum of 3 days off-grid is 360 amps. Plus 10% is about 400 amps, which then directly determines your battery size. So a simple takeaway. Don't guess your system. List your appliances, estimate your usage, and build from there. Because that's the difference between a system that works and one that constantly lets you down. Let's talk about the lighting plan. Most people design by fixture, but the right way is to design it by function. So that's exactly what we did. We divided the fan into lighting zones, each with a clear purpose. General lighting, task lighting and ambient lighting. And that's a great starting point for your own build. You have the general lighting to see the space like you're walking away, task lighting where you actually do things, kitchen, shower, table, and ambient lighting for atmosphere and comfort. If you design with those 3 layers in mind, your lighting will always feel balanced. Now in our fan, the main walkway is our general lighting and also dimmable. You can turn these lights on from 2 locations, the main control panel and from the bed. At the bed, we added both tasks and ambient lighting. Reading lights with USB, a dimmable LED strip, but as I just said, we also added a switch from the main lighting at the bed location. You can leave the lights on while getting ready and turn everything off once you're already comfortable in bed. And this is the most important reason. There will definitely be no fighting over who is going to turn off the lights. Now for the functional zones, we kept it very clear. Showering lighting, kitchen lighting and seating lighting. Each is separated, so you only use what you need. We made the kitchen lighting and seating lighting dimmable as well, so it can function as a functional and ambient lighting. We also added a few smart touches. For example, the overhead cabinet, the light turns on when you open it. And outside, we integrated a dimmable LED strip in the gutter above the sliding door. So whenever you're arriving in the dark or sitting outside, we can set the lights accordingly to what we use it for. And in the garage and technical spaces, simple functional lighting, so you're not searching for stuff in the dark. So the takeaway is here simple. Design your lighting in layers, general tasks, ambient, and divide it into zones based on how you use the space. So how do we actually control it all? Our control panel sits right above the sliding door. The most logical and accessible spot in our opinion. You pass it every day when you enter the van and you can reach it from any other area except the bed. But we thought about that as well, so everything is always within reach. Now the key here is not just having a panel, it's how you organize it. For us, we grouped the switches based on location in the van. The first two control the main lighting. Front switch for the front lights, second switch for the back, the middle two are for the central area, the seating area at the front and the shower towards the back, just like in the van. And the last two switches are closer to the kitchen, control the kitchen lighting and the water pump. So everything plays logically, based on where you are in the van. So your brain quickly learns this area equals these switches. So a good tip will be place your switches on your panel in a logical way. We also use the switches separately from the dimmers. You don't want to reset your lighting every time. Besides lighting, this panel also controls key systems, like the diesel heater. You can adjust the temperature the moment you step inside. And the Victron GX50 screen, where we monitor the entire system in real time. But this is where it becomes interesting. We added remote control in certain components. For example, the water pump. It has a physical switch here, but also remote master switch by the Turbo GX. So if we leave the fan and forget to turn it off, we can turn it off from anywhere. We always prefer to turn the water pump off and highly recommend you do the same. Because if anything bursts under pressure when you're away from the fan, you'll get greeted by a water ballot when you get back. It just adds an extra layer of safety. Same idea of the inverter. It's a powerful system. We rather turn it off when we are gone for safety reasons. About the grey water tank. We have a 93 liter tank with an electric valve and it can be controlled by the GX system. So instead of crawling under the fan, we just press a button when we have to empty it. So the takeaway here, keep your control central, logical and safe. Manual where needed and smart where it adds value. Now let's talk about some extras we introduced in the van, because this is where the system starts to feel really smart in daily use. Let's start at the driver's seat. We have added a small set of dedicated switches there. Each one has a very specific function. First, a master 12-volt switch that controls the battery protect, like we showed you earlier in the video about the batteries. So if we need it, we can cut all the DC loads instantly. We also added a dedicated switch for the DC to DC charger, like we explained earlier in this video. Now one of my personal favorites. We use electrical magnets inside the van to lock our cabinets and drawers. So things like the kitchen and camera charging drawers are automatically locked when the ignition is on. But here is the important part. We did not just wire it directly. We used a relay system so the power comes from the house battery while the trigger comes from the ignition signal. And that separation is key. We also add this 3-position override switch. Position 1 is automatic while driving. Position 2 is always on, useful when parked at an angle. And position 0 is off. And yes, it's very handy to have these override switches as we experienced on the road. It also provides an extra layer of security. This is extremely sturdy and requires a lot of force to break it open once it's activated. Of course, we hope it never comes to that. And then there's something we only use in emergencies, but we feel very important to have. A trickle charge function from the Multiplus. This allows the house battery to trickle charge the starter battery at a low current of 1 or 2 amps, if the engine ever fails to start. It's definitely not for daily use. If you're wild camping in a remote area with no signal and a dead starter battery, that gives you the power to get going again. So it's basically a backup system you hope you never need, but you're glad it's there. Next, internet in the van. We are running a GL iNet 4G modem with a roof-mounted antenna. We chose 4G instead of 5G because it's cheaper, still very common across Europe and more than fast enough for our needs. And then the system itself is future-proof. We can always add an upgrade, like the Starlink Mini if needed. And finally, a small but fun one. We built a dedicated power outlet for the projector in the upper cabinet above the bed. So we can place a compact projector inside, roll down a screen and instantly create a 50-inch setup inside the van. We are using an Anchor Capture Air, powered directly from the cabinet outlet. It's a feature that doesn't seem essential, but we basically have a movie theater in our van. Pretty cool, right? So the idea behind all these extras is simple. Add smart controls where it actually improves your daily life and keep everything flexible, safe and servable, because that's what makes a system feel truly finished.
Alright, I think Brandon explained everything about the electric setup really clear. Even I understand it now, and I don't even like electrics. And since you're still here, you probably don't just want to understand our system, you want to know how to design your own. So I'm going to sum it up to you so you can create your own electrical blueprint. Because as we just learned, a good electrical system in a van is not complicated. It just has a clear order. And most mistakes happen when people start in the wrong place. So here's the exact approach Brennan used that you can copy for your own build. Step 1. Start with your real usage. Before anything else, don't look at the batteries and don't look at solar. Start here. What do you want in your van? What are you actually going to use every day? Fridge, lights, charging, cooking, heating, all of it. This will give you your daily consumption in amp hours. And this is the foundation of everything. Step 2. Size your battery bank. Now and only now you choose your battery size. Not based on what fits, but based on how many days you want to be able to be off-grid and your daily usage. Most people skip this step and just guess. That's where systems fail. Step 3. Choose your charging sources. Now you ask, how do I refill the system? For us, it's driving, solar, and shore power. The key here is redundancy, because if one source fails, you still want energy coming in. Think of it like having multiple taps filling the same tank. Step 4. Design the distribution system. This is where most complexity lives, but it's actually just structure. Battery, main fuse, distribution, everything else, with proper protection at every step. The rule of thumb is every major component gets its own fuse and its own protection. This is what keeps the system safe and serviceable. Step 5. Add control and convenience last. This is where things like control panels, relays, smart switches, and monitoring screens come in. And this is important. Don't design around convenience first. Design around function first. Then you add convenience on top of it. That's what keeps the system reliable and enjoyable to use. The big idea is, if you strip everything down, a van electrical system is just this. You store energy, you use energy, you refill energy, you protect and distribute it, and you make it easy to control. That's it. Everything else is a detail. If you understand this order, the components to build an electric setup, and the basics of electricity, you don't need to copy anyone's setup. You can design your own. And more importantly, you can actually understand what you're building. And now you've basically seen the full system, from batteries to charging to distribution to every single consumer in the van, and how it all connects together. If you made it this far, thank you for watching the whole video. It really helps our channel. In the next video, we're actually going to put this van up to the test. Our first trip. Unfortunately, it didn't quite go as planned.
Dat wil vaak een keer zou gebeuren, maar niet gelijk op dag 1.
But you will see that in the next one.